The topic that I am going to discuss today is differential calculus. So the topic that I am going to discuss today is differential calculus. So in case of differential calculus, we all know if we change the value of x by very little amount, then the value of the function fx change also by a very little amount, and which is written by this formula: the change in the function f of x, which will be equal to this value df dx into dx, where dx is the change in x and df is the change in f. Now we have a geometrical interpretation for this value, that is the derivative df dx is the slope of the graph f versus x. So if we draw a graph of f versus if we draw a graph of slope f versus x, and the graph there can be two conditions. One, the f versus x are in this format, and another condition is f versus x keep increasing. So in both cases the slope of the graph is called df dx, which is the derivative. The next topic that is needed to discuss is gradient. So if we have a function v which is a function of three variables x, y and z, then we can write dv equal to del v del x dx plus del v del y dy plus del v del z dz. Now if we can write this value of dv in this form, that del v del x I cap plus del v del y j cap plus del v del z k cap, and dx I cap plus dy j cap plus dz k cap. So where I cap, j cap, k cap are the unit vectors and along the direction of x, y and z axis. So if we take dot product of these two, we can easily get the value of dv. So we can write dv in this format. Now on the left side can be written as grad of v, and the right side can be written as the position vector. So the grad of v is so the gradient of v is del v del x I cap plus del v del y j cap plus del v del z k cap. Now let us take a look at the geometrical interpretation of the gradient. So we know that dv equal to grad v dot dl vector, and which can be written as, if we take the dot product, that grad v, the magnitude of grad v, the magnitude of dl, and the angle between them is theta, then we can write that the magnitude of these two vector multiplied by cos theta. The grad v denotes the slope Now let's talk about the operator delta. We know grad v equal to I cap del del x plus j cap. We know operator v, grad v equal to I cap del v del x, j cap del v del y plus k cap del v del z, which can be written in the form I cap del del x plus j cap del del y plus k cap del del z, and I am taking this v outside. So if we take only the operator del, it is equal to I cap del del x plus j cap del del y plus k cap del del z. Now this operator, if this operator del, this operator del, if this operator del now if this operator del acts on a scalar function like v, then we call this gradient. Now if this operator del acts on a vector function, then we call this the divergence. And if this operator a acts on a vector function but take the cross product, then we call it the curl. Now the next topic that is needed to be discussed is the divergence. Now the divergence is del dot A, and we know the meaning of del is I cap del del x plus j cap del del y plus k cap del del z into the value of A is ax I cap plus ay j cap plus az k cap. So if we take dot product of these two value, we can write this as del ax plus del ay del y plus del az del z. Now take a look at the curl. For curl, we know the curl is del cross any vector, and we can write the curl in the determinant form. We know that the value of del is I cap del del x plus j cap del del y plus k cap del del z, and the value of A is ax I cap plus ay j cap plus az k cap. So we can write this in the determinant form as I cap j cap k cap, and the value of del first, that del del x del del y del del z, and then the value of a vector ax ay az. So we can find that the value of determinant becomes I cap del az del y del az del y minus del ay del z del ay del z, and next is plus j cap, wait a minute, not the plus j cap, here it will be minus j cap, then it will be del az del x del az del x minus del ax del z, and plus k cap del ay del x minus del ax del y. So this is the curl of a vector. Now if a vector a vector is irrotational, if a vector is irrotational, then the curl of the vector is 0. Again, if a vector is solenoidal, then the divergence of the vector is 0. Now let us discuss the product rules. So we know that if we, for derivative, if we take two functions f and g and differentiate them, we can write it as df dx plus dg dx. Now if we are multiplying a function by a constant value and taking differentiation of that, then the constant will come out and the function will be derivative. We will take the derivative of the function. Again, if we are taking derivative of multiplication of two function, then first function will be outside, then we will take derivative of the second function, and then we will take second function outside, and then we will derivative, then we will take the derivative of the first function. Now if we take derivative of division of two function, that means ddx of f by z, we can take the denominator, square of the denominator in the, and write it in the denominator section. Then in the numerator section we take the second the denominator of this division, and then differentiate the numerator, and again minus of, we take the numerator of this division and differentiate the denominator. This is known as quotient rule. This similar relation holds for vector derivatives. So these rules of derivatives for normal calculation holds the same for vector. So if we take del operator, that means del of f plus g, that will be del of f plus del of g. If we take del of kf, that will be k del f. If we take del of a vector plus b vector, that will be del dot a vector plus del dot b vector. If we take cross product of this, then also this will be del cross A vector plus del cross B vector. If we take del dot k A vector, that will be k multiplied by del dot A vector. If we take del cross k A vector, that will be k outside del cross A vector. Now let us take a look at the rules for the gradient. The product rules for the gradient. So let's take a look at gradient product rules. Gradient product rule. First of all, del of f of g, which will be f of del g plus g of del f. Secondly, del of a dot b, which will be a cross del dot a cross del cross b plus b cross del cross a plus a dot del b plus b dot del a. Now let's take a rule of divergence. So we will take a look at divergence product rule. So grad of f a vector, which will be equal to f we are taking a look at divergence product rule. So divergence of f a vector is f del dot a plus a dot del f, and the second one is del dot a cross b will be b dot del cross a negative a dot del cross b. And the Karl product rule is del cross f a vector equal to f del cross a vector minus a cross del f, again del cross a cross b equal to b dot del a vector minus a dot del b vector plus a del dot b minus b del dot a. Now these are the all product rules that will be needed in the vector analysis. Now let's take a look at all the quotient rules. So first quotient rule is del of f by g, which will give us g del f minus f del g by g square. Again we have del of a by g, del dot a by g, which will have as g del a minus a del g by g square, and we will have del cross a by g, which will have g del cross a plus a cross del g by g square. Now these are the all quotient rule of the vector. Next we will take a look at the second derivatives. Let's take a look at the second derivatives. So if we take second derivative of a divergence, we will get I cap del x plus j cap del y plus k cap del z, and which will be dot product with grad v, which is I cap del v del x plus j cap del v del y plus k cap del v del z, and we will get del square v del x square plus del square v del y square plus del square v del z square. And this second derivative of grad v is written as del square v. This is actually called Laplacian of v. Now let's take second derivatives of a curl, which is del cross grad. This is second derivative. This is curl of a gradient. Okay, so as we can see, that the gradient is a scalar quantity. So if we take the curl of this gradient, it will be always 0, as the gradient of v will be a scalar quantity. So if we take a determinant for this, the value will be a constant, and we will take derivative of a constant, so it is 0. Now we take a look at the gradient of a divergence, which is del of del dot a. Now del dot A is a scalar quantity and we cannot take its divergence and curl. That means del of del dot A is not same as del dot del into A. Again, if we take divergence of a curl, then the value will be 0. Again, if we take a curl of a curl, the value will be del of del dot A minus del square A vector. Now why the divergence of a curl is 0? This can be understood by thinking about triple product, where if in the scalar triple product, if the two element is the same, then the value becomes 0.